So we've looked at climbing, let's now have a look at descending the aircraft. In order to descend the aircraft, it's first of all very important that we have a thoroughly good lookout beneath the aircraft. Having done that, a set procedure follows. First of all, reduce the power, close the throttle completely, having first of all selected the carburetor heat to hot. Maintain the level flight attitude as the airspeed reduces, and just before we reach the known gliding speed, which in this aircraft is 80 knots, we will reselect the known descent attitude. That's the distance between the spinner and the horizon, the descent attitude. Having selected the correct attitude, the aircraft should descend at the correct speed. We will then trim the aircraft. Now, if the speed is too low, we'll select a slightly lower nose attitude. If the speed is slightly too high, we'll select a slightly higher nose attitude. So during the descent, speed is controlled by attitude. You will notice the rate of descent settles at about 700 feet a minute. To recover from the descent, we will reselect the level flight power. As the speed increases, reselect the level flight attitude, hold the attitude back to the straight and level attitude we saw earlier, and then retrim the aircraft. Now, as far as controlling the rate of descent is concerned, we have access to the flaps and we have access to the power. Let's first of all talk about the flaps. When I lower the flaps, you will notice that to maintain the same speed, I require a lower nose attitude. There will be a bigger gap between the spinner and the horizon, better view forward. When we raise the flaps, we'll need a higher nose attitude to maintain the same speed. So the use of flaps will be particularly good, if you like, when we come to actually landing the aircraft, a better view forward. Now finally, the power. Obviously more power means a slightly higher nose attitude to maintain the same speed, less power, a slightly lower nose attitude. So the power will have a direct effect on our rate of descent, which you'll see later. Speed still controlled by attitude.
Descending. Our aim now is to glide the aircraft at 80 knots in a constant direction and to level off at a selected altitude. Carburetor air hot, lookout completed. Throttle now slowly but completely closed with a squeeze of left rudder to maintain balance. Airspeed reducing to 80 knots, note we're maintaining the attitude initially, and just before we reach 80 knots, reselect the known descent attitude to maintain 80 knots. And there we are establishing the descent with a new attitude. Note the new position of the horizon in the windscreen. Airspeed being controlled by attitude. If we're slightly too fast, we select a slightly higher nose attitude. Slightly too slow, we select a slightly lower nose attitude. So during the descent, our airspeed is being controlled by the attitude we select. We're now going to level off at 1500 feet. So, within 200 feet of the required altitude, carburetor air to cold, 100 feet to go, smoothly reapply power and reselect the known level flight attitude. And there we have it, see the new, or rather the old position of the horizon back in the windscreen. Good, so let's now look at the effects of power in the descent. Once again, I've reduced the power, airspeed reducing to 80 knots, and reselected the attitude for the 80 knot glide descent. I'm now going to increase the power to 1500 RPM. To maintain the airspeed at 80 knots, I need to select a slightly higher nose attitude. Still descending at 80 knots, but the rate of descent is reduced. I'm now increasing the power to 18 to 1900 RPM, still maintaining 80 knots. But note now the rate of descent has completely disappeared. The aircraft is now flying level. And if I were to select full power and maintain 80 knots, we'd of course be back in our climbing attitude. So we can see from this that the airspeed is controlled by attitude, but the rate of descent is being controlled by the power. Useful information for when we come to the circuit. Alright, very quickly I'm putting the aircraft back into the glide descent, good lookout beforehand, 80 knots. Let's now look at the effects of flap. I'm now selecting flap down to 20 degrees. To maintain the speed with the increased drag, I'm having to select a lower nose attitude. Airspeed being controlled by attitude, but rate of descent now has been significantly affected by the flaps. And can you see how our forward visibility is so much improved? Imagine a runway in front of us now, much easier to see. Look where the horizon is cutting through the windscreen, very, very high in the windscreen. Now to reduce the rate of descent, again I can increase the power. So power is still offsetting the rate of descent, but I'm primarily controlling the airspeed by small and careful adjustments of attitude.